Okay, everyone hear me properly? Good. So today we're going to talk about AI models. Actually, we're going to build one. Oh, okay. So when I talk about AI models, what I mean is actually deep learning models. And we all know, can you really hear me? Because I can't hear myself. Oh, okay, never mind. So deep learning models, it's kind of inseparable to neural networks. Why is it sometimes? Okay. So the way we're going to do this is like this. First, we're going to go through an intuition, as in how AI works. And then we're going to put this intuition into a real context, as in classify pneumonia or not. And then we're going to break it down into small components of how to build such a model conceptually. I'm going to demo to you how to build the model in Jupyter Notebook. And then we're going to generalize this and then see if we can use it in other scenarios. So it's actually quite packed. So, stay with me. All right, so if we think about how a child might learn the concept of an apple, think about it, how they learn, is that as a parent, we show him picture and we say, this is an apple, this is an apple, this is an apple, this is not an apple, this is an apple, this is not an apple, and so on and so forth, right? So when you think about it, actually, we are trying to make the child generalize the concept of an apple by giving examples. And hopefully he will be able to extrapolate the features, as in, the shapes, sizes, colors, of what makes out of an apple or not an apple. Okay, and then in the end, we're going to test, if we think that he learned enough, we're going to test him. We're going to say, okay, here are some apples you haven't seen before. Can you get it right? That's how we all learn, right? So similarly, neural networks learn like this. If we think about a child's mind as neural networks, and then those images that contain features as an indicators of what an apple is or not is the features, then that's the labels. And those pairs of images and answers that we feed to train the neural network is, the training data set. And then we're going to test, once we think it's learned enough, the neural networks, we're going to validate its performance on the images that he hasn't seen before. So this is what we're going to do. So we know that the first image is an apple. And we say, well, did you get it right? Yeah, he get it right. So 1 out of 3, he get it right. The second one is an apple too, and he get it right. So 2 out of 3, he get it right. So the third one is not an apple, and he says it's an apple, so he get it wrong. So his accuracy stays at 67%. Right? Yeah, so now we know how the neural network learn from an intuitive perspective. We're going to put it into a context that's classify pneumonia here. So what we do is like, the same thing. We're going to feed a bunch of images, that's X-ray images, into a neural network, and we're going to train it with a training set, and we're going to test its performance with a validation data set. Once we're satisfied with its performance, what we do is that we're going to deploy it into an API call so other people can consume this model as well, for real. And I'm going to demo that too. So to break it down a little bit further, this is how we're going to do it. We're going to get the data that's the pair of the images as well as the answer of whether there's a pneumonia exhibited in the X-ray image or not. And then we're going to see if we can find some features that we think the neural network are supposed to learn. All right? And then we're going to construct the neural network's architecture. We're going to choose a framework. We're going to choose the loss and validation function. And we're going to have the training and validation set to actually train the model and test the model's performance. And that gray box there is called deep learning. Once we're satisfied, we're going to deploy it into an API call to consume it. And I'm going to demo that as an example as well. We're going to do all of this in Jupyter Notebook. You with me, everyone? Right, so that's the demo time now. Let's have a look. So, let's see if we can get my, here it is. So as you can see, basically, a notebook, Jupyter Notebook, is a workspace that the data scientist used to document his or her work. And the reason why he or she needs to document the work is because that for reproducibility and transparency, so that nothing he or she do is a black box, right? Because you can cross-examine each other. And as any notebook that you can actually insert text, pictures, actual script. All right? So because of GDPR, I kind of have to tell you where I get the data, so, so I'm not in any trouble. You can see that on the left-hand side there, that's where I get the data from. That's from Kaggle. Kaggle is a competition website for data scientists to actually practice their capabilities. So I get the data from there. Okay? I didn't get it from anywhere else that I'm not supposed to. Okay, let's take a look at the data. So basically, we were going to see some X-ray images for normal lung that has no pneumonia. And we're going to see the X-ray image of the ones that has bacterial pneumonia or viral pneumonia. And these two are going to be grouped into one group that is pneumonia or non-pneumonia. So it's a binary classification, right? So the first thing we're going to do is just to iterate what we're going to do actually. We're going to train the model to identify whether there's pneumonia exhibit in any given X-ray image. So the first thing we do is that we're going to load the data. Here we go. We're going to explore if there's any features. Okay, so this is normal. And then just like the apple that we actually try and find apple have different colors, X-ray image has gray scales. Gray scales are like this. So I want you to take a look at this one and keep track of this one, the proportion that exhibited here. This is the background. This is the organs. This is the transparency of your lung. So you can imagine if your lung has no pneumonia, you should have transparency. But if your lung does have pneumonia, we're going to redo this. So, did you see that? It becomes bigger because you have pneumonia. And similarly, we can see that basically you cannot see your lung anymore, your ribs anymore, right? Just to switch back to the normal one so we actually get a clear picture. Pneumonia, pneumonia, come on. So, see the ribs? See the lungs? So these are the features that we think the neural network are supposed to learn. So let's train it. Let's train a neural network. So we have to actually, like I said, we have to actually give an architecture. So we put layer by layers, as I see here. You add layers and layers and layers. And you define an error, the loss function, and the optimization function. So this is a visualization of that. So you can see for every given X-ray image, it should pass through these layers and layers and being able to know whether it is pneumonia or not. All right? Just to put things into perspective, the neural networks actually has to learn 200,000 something parameters right there in order to actually identify whether there's pneumonia or not. We split the data into training and validation. We use 75% to train a model. We withhold 25% to actually test the model's performance. So here we go. Oi. The training accuracy is 96%, which means that for any 10 on the training data set it was trained on, it's supposed to do good, right? So for every 10 image, it actually makes 0.4 mistakes. That is very good. For the validation data set, it hasn't seen those images before. It's 88% accurate. So that's pretty good. So just to want to convince ourselves, we wanted to be prudent because this is medical. So let's take a look at the training process. So here are the epochs. For epoch means that for every time you went through the 75% of the training data set, you're supposed to learn something. So your accuracy goes up and your error goes down. And you can see it. The accuracy goes up, the error goes down. So this is very, very healthy training looking neural networks. Again, we wanted to convince ourselves because it's medical. So let's have a look. You can see the X-ray image is coming from the downstairs, and it actually being able to, you see the ribs cage over there on the top right? And you see that the background image is being subtracted. So they actually learn those features that we think it should learn. So that's a very good looking neural network that we have trained. I'm just gonna stop this so it doesn't consume my, yeah. Okay, so now we have a model ready. We're gonna put it in production now. So this is one of many ways you can do it. The way I do it is that I'm just gonna put it in Azure Databricks, and I'm gonna deploy it as a web service, and I'm gonna get a URL back. And that's what we're gonna do next. So this is my Azure Databricks, and that's how the notebook actually looks like. So we deployed it. I'm gonna spare you all the long sequence of stuff, but anyways, we deployed as web servers, and we get the URL back here. So what we're gonna do next is this. This is what I'm gonna do. Here we go. I'm gonna start up a server now. I built a very silly looking web page in order to take in the image in order to make the prediction. So as you can see, now that I have the URL, so this is a silly web page. I'm gonna submit a new image. I'm gonna upload it. So in the background, the server is, what is the server gonna do? The server is going to take the uploaded image, call the model, make a prediction, and give the prediction back as in the title. So we're waiting any minute now. Come on, come on. Yeah, there we go. So the picture is being uploaded, and the scoring has been done. So you can see that, there you go. That's your original title. It's pneumonia bacterial, and it's pneumonia predicted. Now, what we have learned now is that we know how neural network works. And then we build a model, and we deployed it so we can consume it. We're going to generalize to other scenarios that we think can be of your interest. So here's the first example. This is actually where I live. I live in Gothenburg, and this place is called visar. I'm going to advertise that. That's the bus stop, and that's Coop. That's where I usually do my shopping. So we send in a video. We want the neural network to be able to do segmentation and color it. There you go. It's doing pretty well. Okay, so the next one is the normal one. You know, you wanted to classify like, cats and dog and bird. And you see it? Cats and dog and bird, it's being classified and bounding box it. So this is object detection, very normal. This is a bit of our normal one. So you have a raw CT scan. It's an actual CT scan raw image that you feed it into the left-hand side. And you train a model to be able to segment and find out the organs inside of your abdomen. So you have liver, you have pancreas, you have stuff like that. So this is the last one I'm going to leave you with. Yeah, by the way, I'm not very good at this game, so I train a model to actually be able to do that for me. So you can see it's doing really well. I'm really happy. I'm really stuck at it. So that's it for today. And I really, really hope you enjoyed it.